Um, all right. This is an extra video basically helping you to prepare for your presentations. As I described, you guys need to be able to form a group from groups and then pick up data structures on an algorithm that you haven't seen in class and make a presentation and send the presentation slide to me. Right here, I'm just going to go through the rough outline of your presentation. Basically, I'm going to let you see that what would be my expectation of your presentation, what components it need to contain, and what sort of explanations you need to deliver. Right. So here I'm going to use a minimum spanning tree as an example, and I'm not going to fill in all the details because I do allow you to choose the minimum spanning tree to do the presentation. So if I fill in all the details, then basically you can copy mine, right? Um, so basically, first, here's the outline of what you need to present. You need to start with the introduction, describing the background, and then the next day you need to move to help the audience to understand the intuition of the algorithm. Sometimes you also need to explain the key challenges in designing the algorithm. And then next, you need to be able to move to explaining the pseudocodes of the algorithm and describe some of your analyses. Right. At the end, you need to make a conclusion. Right. So let me start with the introduction. Right. So in the introduction part, the most important and the most crucial component is that you need to be able to articulate what sort of problem you want to be able to solve. Right. For instance, in the minimum spanning tree, the input will be an undirected and weighted graph. And then you need to be able to explain what is the output, right? So there are really two components here. First, that you need to be able to explain what is the spanning tree, right? So spanning tree basically is that you need to be able to construct a tree out of the graph you are given, and this tree has certain property. And then you need to be able to explain what is the cost of the tree and how do you define the minimum spanning tree, right? So this is really just the first line is usually is about a little bit abstract mathematics that's really articulating the problem you are trying to solve. And the next, like, you need to be able to move from some abstract mathematical discussions to a little bit of the concrete examples. So here, usually you really just want to be able to give the audience one or two examples of the graphs. And then for this one or two graphs, how do you find the minimum spanning tree, right? Just tell us what do the minimum spanning tree look like for the two example graphs you are presenting, right? So basically here then you are able to give the audience a bit more concrete ideas of what you are solving, right? So basically that's probably pretty much it for the introduction, right? You don't need to be too long. Maybe it's really just around 5 minutes of the introduction. And then next, you need to gradually move into like the intuition of designing the algorithms, right? So for instance, when we want to be able to find a minimum spanning tree for the graph, you usually need to be able to execute some sort of greedy algorithm, right? So you need to just articulate what would be the objective of the greedy algorithm, right? How can you gradually use a lot of great locally optimum decisions, and then eventually you build up a globally optimum spanning tree, right? So basically, you sort of need to connect your algorithm back to the greedy algorithms we are talking about, like what sort of principles you are applying, right? And also at the same time, right? So you sometimes you also need to explain why designing an algorithm for this particular problem is challenging, why it's exciting to watch your video, right? So for instance, one specific form of the minimum spanning tree algorithm is you keep adding the minimum edges, right? Unless that when you add one new edge, right, then a cycle is formed, right? So at some point, one challenging part of your algorithm is to determine whether after you add a new edge on the existing tree, it's going to form a cycle, right? So basically, maybe what I'm talking about is not that comprehensible if you don't know minimum spanning tree. But the really high level idea is that you sort of need to highlight that, well, if I want to execute my intuition, like what would be the difficult part and how are you going to tackle this difficult part, right? So basically it's you should really aim to make your presentation exciting and explain to your audience why they should care about the design of the algorithm you are presenting. Right. So here's the intuition of the algorithm. And so before the pseudocode, sometimes I also want to, sometimes for me, maybe you have seen a lot of lectures I presented, right? So maybe you also describe one or two very concrete examples telling us that if you execute this algorithm, like on a specific example, like how does this algorithm look like, right? So one or two concrete examples will really just help the audience to understand the very key concept of the algorithm you are designing, right? And then the next then you really need to move to the pseudocode and the analysis, right? So basically, maybe you just outline the pseudocode and then gradually walk us through each line of the pseudocode, right? Of course, like here you need to fill in the pseudocode on your own, right? After the pseudocode, then we sort of need to move to understand the mathematical structure of the algorithm or data structure. Like usually, it really consists of two components. The first component is that you need to show why this algorithm is correct. Right, it's we have been doing this like for a lot of lectures, right? So like in case like you really want to understand like how can you deliver a clear presentation of the correctness proof, you can just look at any of the lecture slides we present, right? After showing the correctness of the algorithm, then you need to move to the running time analysis, because of a lot of times, right, we do, as I described it very early in the lecture in this class, right, a lot of times we care about being able to design an algorithm both fast and the algorithm is correct, right? So you sort of need to explain or justify why this algorithm is fast, right? So this is the pseudocode, and usually it may take you multiple slides to really walk through the entire pseudocode, right? After the pseudocode, basically you can just wrap up, right? So in order to wrap up, basically you can definitely just reiterate the key messages of the algorithm. So what's the principle the algorithm using, like for the spanning tree is the greedy algorithm, right? And what's the performance characteristics of the algorithm, right? Sometimes it's also interesting to connect the specific algorithm you are presenting with other algorithms that can equally solve the problem, right? For instance, in the case of the minimum spanning tree, like there are all multiple ways of doing the greedy algorithm. So maybe it will just be interesting to for you to really just compare all different algorithms. Why sometimes people prefer algorithm A, sometimes people prefer algorithm B, right? Making a bit of the discussions, right, to just make people become more knowledgeable of the background of your algorithm, right? So that's really just pretty much it. It's not going to be I don't think it's going to be that challenging, right? So and also like this is the next slides basically they'll tells you a bit of the time allocations. Usually people spend 5 minutes to describe the structure, the structure of the problem, the definition and the background, and another 10 minutes to talk about the intuition, and sometimes, as I said, explain the key challenges in designing the algorithm. Of course, like you need to present one or two very concrete examples on how the algorithm works, and then maybe another 10 minutes about the pseudocodes and its mathematical analysis, and finally you spend somewhere between 3 to 5 minutes to conclude. And as I said, like my expectation is that if you form a group of 3 students, I hope that you can have a presentation that's around 30 minutes. And if your group has only 2 students, your presentation can be somewhere between 20 to 25 minutes. And in case you are playing solo, right, I expect your presentation to be somewhere between 15 to 20 minutes. Sorry, 15 to 20 minutes, right? So basically, depending on the size of your group, basically you need to scale down the length of the presentation length for each of the components on your own, right? Finally, it's a bit about the logistics, right? So about the recording technologies, I'm pretty sure most of you are better doing this kind of things than me, right? So for me, I just use the iPad and I do the recording using the built-in iPad functionalities. And I'm pretty sure that this can be done by using the PC or Mac, right? I also heard that this can be done by using Zoom, but I haven't done that on my own before, right? So in case you have questions, just email me. We can sort out the details. And for concretely, what you need to do next is that after you sort of have an idea of what you want to present and build up a skeleton of the presentation, you need to email me for an appointment. This appointment is counted towards the third mandatory meetings in the office hours. Please do that by November 9th. And when you email me for an appointment, just tell me your group members and tell me your topic, right? So I do prefer to have the appointment to be within the office hours, but I'm pretty flexible now because we are all heading towards the deadline, the finals. I'm aware that you are busy and maybe you are not that flexible in terms of your own schedule. So I'm trying my best to accommodate each of your schedules, right? And also, like in terms of the submissions of this piece of homework, email me your lecture videos by the final exam date, and that's our sort of official deadline. And because this is required by the university, we cannot accept any homework submissions after the exam date. But in practice, I'm going to accept. Basically, it's really just that if you miss the deadline, but you don't miss the deadline that much, I'm not going to put any penalty on you. So effectively, really just make sure that you can submit everything by the end of this month. Then I'm going to be happy with that. All right, that's pretty much for the whole explanation of what you need to do for your presentation. And in case you have additional questions, Ray, just feel free to email me or Skype me. And I'm looking forward to talking to you again, right, and seeing your presentations. And see you soon. Bye.